Let us get started. Thank you so much for taking the time to come through. Welcome. I will be taking you on a reflection journey where I attempted to add baseline profiles to my production app and whether there was any improvement or not. The main part of the app I was hoping to improve with these baseline profiles was the app startup. With this, I wanted to try and address a visible lag that I saw, or rather a slow startup. So, welcome to my journey, adding baseline profiles to a production-based app. Success or failure? I am Ahmed Tikiwa. I'm a software engineer. I work at a company called Bol.com. I am based in the Netherlands. Bol.com is basically an online shopping platform that operates in the Netherlands and in Belgium. I used to stay in Cape Town, and I relocated to the Netherlands last year. I'm also a Google Developer Expert in Android. In fact, tomorrow I will be celebrating a year of being a GDE, and it was actually here at DroidCon Berlin where I received the news as a GDE. You can find me on Twitter using that handle at Ahmed_Tikiwa. So, what are we going to be talking about today? We've got the app, so I'm going to tell you more about the app itself that I added these baseline profiles to. We're going to touch on the app startup process, cold, warm, and hot. What startup metrics can we measure? What are baseline profiles? Creating baseline profiles, testing the baseline profiles, and of course, the results of whether this was a success or a failure. So, about the app. The app is UpNext TV Series Manager, which is an app that has been in production since 2015 and available for download on the Google Play Store since then. To date, it is about 2,000 installations. I also made the code open source, and it is part of the Google Dev Library. And if you haven't heard about it, it's basically a platform containing open source projects and content that use Google tools and technologies. And then all this content and projects have been curated by Google. So all the code that I'll be presenting within this talk is part of the project, UpNext TV Series Manager. So the app contains four main entry points, via a bottom navigation. It has a search screen. It has a dashboard screen, which is a screen that shows the TV schedule for the previous day, the current day, and the next day. It has an explore screen, which is basically a screen that shows popular, most anticipated, and trending shows. And finally, it has an account screen, which is a screen for showing the user's favorite shows. The nested screens within these main screens are the show details screen, the season screen, and an episode screen. And then the information that I get to display all this information, I'm retrieving it from Trackit and TVMaze APIs. The app itself is also featured by Trackit as one of the apps making use of their API on Android. So those are the different apps that are there right now. And UpNext is one of them. That's my logo there. So when the app is launched for the first time, it goes through a class called UpNext Application. And this is a class I created which basically extends the Android application class. It overrides the onCreate function and calls a custom delayed init method. And then inside this delayed init function is a call to launch background tasks, which is launched within a coroutine scope. And then inside this function, Work Manager is initialized, and then it's used to set up 3 different workers for fetching data from Trackit and the TVMaze APIs, which will be set up to be executed periodically in the background at defined intervals. Then the favorites worker is only executed when the user is logged in to their Trackit account. If they're logged in, it makes a request to the Trackit API for the user's favorite shows. the images from TV Maze are under Creative Commons license, unlike the ones from the Trackit API, which you can't really freely use. And so to be able to rightly display images within the app, the images from TV Maze are the ones that I use, and these are displayed across the app, regardless of the source of whether I'm using Trackit or TV Maze. Then a request here is made to TV Maze for the images for the favorite shows. Then the response is stored and cached in the room database, as you can see there. Then you have the dashboard screen, which contains 3 horizontally scrollable lists. Shows for the previous day, current day, and the next day, as I said earlier. Then we have this dashboard worker, which makes a request to TV Maze for these schedules, yesterday, today, and tomorrow. Then the images are already contained in this response, so I don't need to make any additional calls. And the response is then cached and stored in the room database. So like the dashboard screen, there's another screen called the Explore screen. And then this screen shows the popular, trending, and most anticipated shows, and makes 3 separate calls to track it. From this request, another request is made to TV Maze for the images, and then the entire information is then stored and cached in the room database. And then I'm also using the Jetpack app startup library, which comes built inside Work Manager since version 2.6. So there is some sort of optimization already being provided by the app startup library. I also want to build a backend server that will act as a mediator and collect all this information that you see there from the different APIs, the favorites, the right images, and so forth, and then take the pressure off the app. But this is a future improvement. So the app startup process. To be able to understand how baseline profiles works, we need to understand the different startup times. In other words, knowing or understanding what is happening at the system level. The point at which your app becomes visible to your users is affected by these states. And these states, you have cold start, warm start, and hot start. The cold start is basically when an app is started by the system from scratch. And in other words, this means that the application process has not yet been initialized. This happens the first time the app is launched after a device is booted up, or maybe if the system has killed the process. The time it takes for your app to finally become visible to your users is higher in this state, in the cold state, than in the other states, warm and hot. And thus, reducing the time to startup within the cold start is regarded as a challenge. So as you can see in the diagram, the system does 3 tasks. It loads and launches the app, it displays a blank starting window, and then the app process is then created. The system has now created the application process, and that is now responsible for bringing the app into the view where the users can finally interact with it. It starts off by creating the app object. In the case of my app, because I've overridden the onCreate method within the application class, this will get invoked. At this point, the blank window is still in view. So in other words, your users can't interact with the app yet until the drawing of the app for the first time is completed by the system. Then the app initializes the main thread, also known as the UI thread. And this is given the responsibility of then creating the main activity. When the activity is then created, it executes 3 tasks. It initializes values, it calls constructors and the callback methods that will be in line with the life cycle of the activity that it's currently using. For example, activity.onCreate. And then onCreate itself, it actually impacts the load time greatly because the amount of work that it has to do, in particular loading and inflating views and initializing objects that are needed for the created activity to actually run. Then the system swaps out the currently displayed background window, in other words, that skeleton window that was there, and then it replaces it with the main activity. It is then at this point in time that your app becomes usable to the user. Then we have a warm start, which is faster than a cold start, but still slower than a hot start. And this is basically in terms of the overhead that is there. In a warm start, a portion of the flow of the cold start is actually present, but the way a warm start occurs is in many ways. And there are two possible ways. If the user relaunches your app after initially backing out of the app, even though the process may have continued to run, the activity needs to be recreated from scratch through calling the activity.onCreate. Another possibility is if the app gets removed from the memory and by the system, and it is at this point that the process and the activity then need to be restarted. But if there's a saved instance state, so if you've actually done that within the app itself, then the app process or the warm start process can actually benefit from this. Then the hot start is faster than all of them, than the cold start or the warm start, because the steps to bringing your activity to the foreground is actually much quicker because of the number of tasks that it has to do are much fewer. Initializing of objects, inflating the layout, rendering, and so forth are not repeated as long as the activities for the app are still in memory, or rather, that they have not been trimmed by the system. Thus, all the system has to do in this state, in the hot state, is just bring the activity to the foreground. A blank screen is then swapped out by the system, and then the activity is then placed there. So in my case, this is how the app actually looked, right? Before I added baseline profiles. The dashboard screen is the entry point for my app. So when the user actually launches the app for the first time, this is the default screen that they will see. As you can see, there's a bit of a wait before the content of the screen is initially displayed. Because baseline profiles helps with startup, this is what I was hoping that baseline profiles would assist with. So, what startup metrics can we actually measure? The first startup metric that we can measure is called time to initial display, which is basically a metric that measures the time it takes for an application to produce its first frame. Also, it includes the process init, which is part of the cold start. It includes the activity creation, which is also part of a cold or warm start, and then displaying of the first frame. Then we've got TTFD, which is the time to full display, which is a metric that measures the time it takes for the app to produce its first frame with full content. In other words, the content, the app is visible to the user in a state that they can now interact with. So now everything is finished in terms of the process and the application. Now your user is now able to interact with your app. At that point in time, that's now the full display, TTFD. It also includes the content that was loaded asynchronously. And typically, this is how apps are loaded. There's sometimes you have to fetch data remotely and then load it onto the system. So time to full display includes this metric. Then you can use the activity.reportFullyDrawn, which is a method that you can use to report whether your content is now available for use for the user, or if you're using Compose for lazy loading scenarios, then you can use reportDrawnWhen. I will show later how I actually use reportDrawnWhen in my app. So, all this talk about baseline profiles, but what are they actually? Baseline profiles are a list of classes and methods which are compiled ahead of time. In other words, it's doing the opposite of just-in-time compilation. Over the years, there have been some improvements with regards to how code is compiled, from interpreted only to just-in-time to ahead of time to back to just-in-time with guided profiles and so forth. And so baseline profiles aims to improve on all these compilation methods that have been introduced over the years. And basically, this baseline profile, or classes and methods, they're compiled on every installation of the app on the device on every update. Then with these baseline profiles, apps can make improvements to startup. They can reduce skipped frames, which we also call jank. Then make runtime performance improvements for the users of your app. With baseline profiles that are generated, you can also generate these for your apps or for libraries. And with libraries, these rules can be generated and distributed such that every user of your library will benefit from the baseline profile that has been provided. Now, Jetpack Compose is actually such a library that already has a baseline profile included in it. So when you then use Jetpack Compose within your app, you're already benefiting from the baseline profiles that have been included, which is very cool. And then it is recommended that the baseline profiles that you generate are for the critical parts of your app. In other words, the areas that you feel the users interact with the most, that you feel that, you know what, I need my user to have a smooth and fast experience when they're interacting on this particular screen. So the benefits. Through including a baseline profile for an Apple library, this results in the Android runtime, optimizing the code parts through the use of ahead-of-time compilation, or AOT. And this is also referred to as the profile-guided optimization, because AOT is also using a profile. The inverse of this is when a profile is not used, then just-in-time compilation is what is then executed after being interpreted or compiled into what is called an ODEX file in the background. Then baseline profiles can help improve startup, screen navigation, and content scrolling from the first time the app is run. Users want an app that is smooth, that is fast, that doesn't have any lag whatsoever. And often, if they don't get this experience, they will either leave a bad review for your app. Trust me, that's not nice. And then, or they might just abandon your app completely and not even leave a review. Or maybe they might do both. You obviously don't want this for your users, and you want them to actually experience a smooth experience with your app. Then Google Maps for Android also saw an improvement with baseline profiles. And here you can see by using baseline profiles, Google Maps improved their average startup time by 30%, and saw a corresponding increase in searches by 2.4%, an immense gain for such an established app. So how do you actually create baseline profiles? Well, there are two ways. To be able to take advantage of build improvements when using baseline profiles, it is recommended to use the Android Gradle plugin 8 or higher. In this app, in Up Next, I'm using the AGP 8.2.0 Alpha 09. So it's one of the latest versions. Then the baseline profile is generated by a specialized macro benchmark test. Once this profile is generated, it is extracted from the device under test and then placed into the app source main folder for the profile installer to pick up. The profile installer is responsible for picking up and installing the baseline profile during app installation. Then, as I mentioned, there are two ways of generating the baseline profiles for your app or library. You can either do it through the new baseline profile generator module template, which is found in Android Studio Hedgehog, or later, bearing in mind that Android Studio Hedgehog is currently in Canary, so it's not yet stable, or by manually creating the module as well as the profile generator. For this talk, the focus will be using the baseline profile generator module template, which is found in Android Studio Hedgehog. And you will see how simple it is to actually create it. So, to use the profile module generator, you simply right-click on the project, then you select New, then you select Module. Then you will be presented with a screen like the following as you see there. And then on the left are various templates that you can see, phone and tablet, Android library, and so forth. But the baseline profile generator there, so you will see this in Android Studio Hedgehog. And this is where you will click it, and this is the window that you will see there. In this wizard, you basically have to configure certain things. So you need to specify the target application, which is the app module to generate the baseline profile for. As you can see there, up next to the app is the module I'm targeting, the main app module. Then you can give it a name, whichever name of your choice, the package name, the language of the module, Kotlin or Java, the type of build configuration, whether you're going to use the Kotlin DSL or whether you're going to use Groovy, and finally, whether you want to use Gradle managed devices or a physical device to generate the baseline profiles. It is recommended that you use one of these options and not really an emulator. However, I found that the Gradle managed devices to be quite temperamental, and sometimes it actually wouldn't run. So I actually ended up using a physical device instead, connected via USB. This was actually more reliable. Then, when the module is generated by the wizard, it generates the baseline profile generator and startup benchmarks as stub test classes. Here in the generated baseline profile generator will be an area where you can specify the interactions you want included in the baseline profile. The startup benchmarks test class is another generated class by the module wizard. And the aim of this is basically to benchmark whether the startup under certain interactions and then provides two sets of data. So it'll provide you data where there is a baseline profile and data where there isn't a baseline profile. Then these test results will include startup timing metrics, which is basically the time to initial display, TTID. And then if you use the report fully drawn method, or report drawn when in my case, then it will also include the time to full display metrics. So it will have both of them, and I'll show you later. Then I created this class called the scroll benchmarks. It's an optional one that you can create. And basically, it's to help you benchmark the scrolling performance of your app using baseline profiles and without. The metrics for this test will be based on what is called the frame timing metrics. And as mentioned earlier, it is the startup benchmarks that I actually were more concerned about because I needed to improve the startup. And so this was the focus here. And then here's the structure of the baseline profile generator class. So it uses a baseline profile rule, which will contain the necessary code for generating a baseline profile. In particular, we will be using the collect baseline profile method, which is from the rule, which will be used to create the baseline profile. It requires two parameters, the package name for the app and the baseline profile, the app that the baseline profile is being generated for. And then you're going to have a profile block lambda. And it is within this profile block lambda where you're going to specify the different interactions that you want the baseline profiles to be created. The test class contains one method, which is called generated. So this is by default. When it generates for you, it will contain this method called generate, which is a test method. And it uses the collect baseline profile method from the baseline profile rule to generate a baseline profile. That's a lot of baseline profile. The profile block, where the interactions are defined, will run several times. And this is basically to iterate and get the best results over time. Then during these runs, the method will basically collect all the functions, all the classes, all the methods that were executed during these runs. And then once it's gathered all the data, it will generate the baseline profile on the device under test. Then to be able to access any composable that uses the modifier or test tag, you need to have this test tags as resource ID to be enabled in your hierarchy tree for your composables. Then with this, your composables with this test tag are now accessible via the UI automator. It only needs to be enabled once in the hierarchy tree for your composables. And so here you can see I specified it in my main scaffold.kt, and then I have a composable called scaffold, and there I just defined it there once. And then all the composables that fall under there, I'll be able to access them via the UI automator. Then the composables on the dashboard screen are what I'll be passing to the UI automator, because like I said, this is part of my startup. This is what the users will see when they open up the app for the first time. And so this is where I'll also be defining the benchmark tests. So here I've specified and modified a test tag, and I've given it a name called dashboard_list. Then here I've specified the modified test tag for a show item in the list of shows that are displayed on the screen. And I've called it show_item. Then here I've told the system that regard the dashboard screen as fully drawn when there is at least one schedule that is not empty. So I've got these different lists, yesterday's shows, tomorrow's shows, and today's shows. So as long as one of these lists is not empty, then consider my screen as ready for use. And then this is how I let it know in my composable, report drawn when, and this now lets the system that this is now the time to full display when it hits this point in time. Then the first interaction the profile block will do is to press home. Then it starts the default activity for the app, and then waits until the first frame is rendered on the screen. The next three interactions are waiting for asynchronous content to be displayed. Scrolling up and down and going down to a specific show detail. Then, here's what the wait for async content will look like. This is basically the entry point, as with most of the screens in the app, is asynchronously retrieved before being displayed on the screen. Then the aim of this function is to basically fetch the content, at which point where it can be interacted with on the screen. So first here, when we are waiting for the async content, we wait until the composable with the test tag dashboard_list is actually available to the UI automator. Then we assign a variable to the dashboard_list, marking it as an accessor to the child content. Then from this dashboard content on the screen, we wait until there's a composable with a test tag show_item. It is at this point that the async content is now ready for interaction on the dashboard screen. Then the scroll dashboard list journey is an interaction to scroll up and down the dashboard content on the screen. Then the composable with the test tag dashboard_list is then searched for, as you can see, so it'll find the object there. And then in order to avoid accidentally triggering system navigation, we define what the gesture navigation or gesture margin should be by dividing the display width by 5. We then scroll up and down the list using the fling method, starting by scrolling down, then scrolling up, basically mimicking what the user will be doing when they interact with the app. Then we wait until the UI settles from the up and down flinging, and then until it's actually passive enough for us to interact with the item on the list. Then the go to show detail journey is an interaction to navigate from the list to a specific show detail, which is what the users of the app typically do. Then we start by finding the composable with the test tag dashboard_list. Then from the list, finding the composables with the show_item test tag. Then we pick a specific show from the list. Then from the selected index, we perform a click on the show item. We wait until the list is no longer on the screen to mark the navigation as complete. So, as mentioned earlier, there are various options to run the baseline profile generator. Either you can do it through a Gradle managed device or through a rooted device or emulator, or non-rooted Android 13 and above device. So if you want to use Gradle managed devices, this is how you would define this in your Gradle file inside the Android block of the baseline profile modules build.gradle file. Then below the Android block is where you would define the list of managed devices. Notice that the use connected devices there is set to false. So you can't have one or the other. So either you use managed devices or you use a connected device. In the same file, in order to use a connected device and not a Gradle managed device, you simply remove or comment out the managed devices section, and then specify use connected devices equals true. Then that is what I did in my case. Then to run the baseline profile, you first need to ensure that the configuration is correctly set up. This should be automatically set up for you, but if you run into issues, then you might need to just update the configuration here. In my case, I actually did have some issues because it picked up the wrong app module there, and I had to update it. Then this is how the run command, as you can see in the top there, so basically this is just magnified. This is typically how it will look and how you could also run it from the command line to generate your baseline profile. Then when you run the profile generator, this is what it will look like. On the left is the process itself, running through all the relevant tasks, including the instrumentation tests. Then on the right-hand side is what it will look like on the profile block when it executes the different interactions I specified. So I'm waiting for the async content to be loaded. Then I'm scrolling down the list of shows. And then it will do this several times, as you can see. So this is running through all of this until it's actually satisfied. Then once the process is complete, the baseline profile is generated, and it can be found in a folder called Release Generated Baseline Profiles folder as a file called baseline-prof.txt. Then the contents of the file are what you see on the right-hand side. Makes sense, right? So this is basically the list of classes and methods, as I mentioned earlier. So it collected every single method and function, all basically what was executed during the different interactions, and made a list of it here for optimization. Then, testing the baseline profile. To benchmark whether the baseline profile was indeed an improvement or not, success or failure, we can test this inside the pre-generated test class for benchmarking the startup performance. The class uses a macro benchmark rule, which is used to run the app benchmarks and then gather the required performance metrics. There are two tests defined. The first one is to benchmark without any baseline profiles, and then the second one is to benchmark when you have baseline profiles included. So as you can see, the compilation mode.none is a way to define that I want you to test it without any baseline profiles. The second call calls the benchmark method, and then in this class it passes the compilation method of partial, and then it says that the baseline profile mode .require, meaning we want to use the baseline profile that was generated as part of the benchmark test. Then the benchmark method requires a compilation mode as an argument, and then it uses the measure repeated function of the macro benchmark rule. The measure repeated function has several parameters. The first one is the package name, which is the app under measurement. Then it has the list of metrics to be gathered or measured. In this case, because I'm testing the startup, I'm going to be using the startup timing metric as part of this benchmark. Then it has the type of compilation mode that will be benchmarked in this particular test. So there are 4 compilation methods available. You've got default, meaning partial app pre-compilation with baseline profiles will be done only if they're available. And then this will actually act as the default compilation mode if you don't specify anything. Then you have none, which is the compilation state is reset. There's no compilation that is done, and just-in-time compilation is actually what is going to be used. Then you have partial, which is the app is pre-compiled with baseline profiles, or it performs warm-up runs, or it does both. Then here, the entire app is pre-compiled, and this particular option, full, is only available on Android 6 and below. Then going back to the parameters for the measure repeated is the startup mode. Here, as it is set as cold because that is the optimization that we actually want. We want to mimic the app being launched from a cold start. And this is a recommended way. Then here, you specified the number of iterations of the benchmark you want to be repeated. Here, I specified 10. Then here we've got two blocks. We've got the setup block and we've got the measure block. The setup block, basically you say whatever interactions that you want to happen before the benchmark tests are run. And then in this case, it's just basically just going to start from the home screen. Then in the measure block, we start the main activity and wait for the first frame to be rendered. Then we wait for the async content to be loaded and then to be retrieved and displayed on the screen. Here's what the startup benchmark test looks like. On the left-hand side is a different test being executed, and then on the right-hand side, this is what it will look like on the device. The tests are for when there is a baseline profile and when there isn't. And this is visible in the way the shows are displayed on the screen. Then this is the scrolling benchmark test, when it loads the different lists on the screen and scrolls up and down through the different lists. And finally, we have the results. The startup benchmark results, as you can see there, so these are the results that it will display once it's done running. And the focus here is primarily in the median there, so the average that we're going to be gathering from this. As you can see, when it ran with none, 424.1 milliseconds, which was the time to initial display. And then the time to full display was 630 milliseconds. With baseline profiles, 368.7 milliseconds. With baseline profiles for the time to full display, 486.6 milliseconds. So, startup improvement, was it a success? Success or failure? Well, I'm happy to report that it was indeed a success. As you can see there, the time to initial display was an improvement by approximately 13.06%. The time to full display was an improvement by about 22.79%. You can actually see the difference here between the two apps. This is an app that, an old version of my app that didn't have baseline profiles. I'm talking maybe 5 versions behind. And then this is the one that now contains the baseline profiles. As you can see, there is a visible difference in the way when the shows initially get loaded, and then here, blink of an eye, pretty much. And this is the difference now between using a baseline profile and without a baseline profile. Then, tips or learnings that I have, which I'll have to run quickly as we are running out of time. So basically, the build variant, when I was running the benchmark tests, for some reason, the app variant was defaulting to benchmark release. So just make sure when you actually run your benchmark test that it's selected non-minified release. You basically select the Android icon there in the top there, then you'll see the list of build variants, and then select non-minified release. So in my case, it was defaulted to the other one. But you can just make sure that it's using the other one. Then, Gradle managed devices, as I mentioned earlier, sometimes they were temperamental. This is the error that I would get. So sometimes I would try to run it, and Gradle will just say, sorry, I don't have any devices for you. It's not available. So I found that using a physical device to be much more reliable. Also, use it using USB connected, because sometimes using the Wi-Fi was also unreliable. So connected physical device. Then the UI automator, as I mentioned earlier, if it doesn't find your composable, it might be because you haven't added this test tags as resource ID equals true within your composable tree. So just make sure that this is enabled, and then you'll be able to interact with your UI. And these are the list of resources that you can get, how to understand baseline profiles, testing your composable layout. You can also get information on my code, UpNext TV Series Manager. As I mentioned, it's on the Google Dev Library. You're all welcome as well to contribute if you'd want to. And then writing tests with the UI automator, that's more information there that you can find there. And thank you. I am Ahmed Tikiwa. I'm Ahmed Tikiwa. You can find me on Twitter at Ahmed_Tikiwa. Connect with me on LinkedIn. If you have any questions, feel free to reach out to me. I'm more than happy to help. And thank you.